Welcome, everyone. Thanks for joining. Welcome to our last Cropping Convo for this season. Thanks for jumping on your Thursday. My name's Courtney Young. I'm the Peer Learning Manager at Soils for Life. A little bit about Soils for Life before we kick off. We're a not-for-profit based around Australia, and our mission is to support Australian farmers to regenerate soils for resilient and healthy businesses, landscapes, and communities. This Cropping Convo is part of our Cropping Resilience project. And as part of this project, we're running a bunch of events like today's. We've had some field days, podcasts. We're also releasing these really fantastic practice guides on different cropping practices that can help you to build more soil health and resilience into your cropping system. We also have some cropping discussion groups. And we've run a bunch of webinars, all of which you can find the recordings on our website. For those who haven't come along to one of our Cropping Convos, this is an opportunity to ask questions, have a discussion. It's not a traditional webinar format. So please stay on mute until we get to question time. Matthew's going to present for 10 to 15 minutes to give us a bit of an introduction to the topic. And then we can start typing questions into the chat and go through everyone's questions. Leave your camera on. We'd love to see your face, so we're not just talking to little black squares. And you can, again, head to our website if you'd like more information. So I will hand over to Matthew. So Matthew, I have your bio here somewhere. Matthew Newell is a research officer with the New South Wales Department of Primary Industries. Since 2008, he's been one of the lead investigators into perennial grain research. And it's the only perennial cereal research program in the Southern Hemisphere, which is quite impressive. Matthew's based in Cowra, New South Wales, and he's currently looking at the nutritional value of perennial cereals as part of a dual-purpose graze and grain production system. So thank you, Matthew, for jumping on.
Thanks, Courtney, and good afternoon, everyone. So I've just recently come from the 2025 Perennial Grains Conference, which was held in Mexico this year. And that gathered 100 scientists from across the world, all working on perennial grains. And there's quite a lot of enthusiasm within the group of what's been achieved so far and what we can progress with this new technology. So I'm happy to share some of the results that we've been working on at the Cowra Research Station. So to start off with, why we're interested in perennial grains, we need to have a little lesson in ecology. And if we think about grasslands, and it's the same whether we're looking at a savanna in Africa or a grassy box woodland, which we might be more used to in Australia, they all have several things in common. And firstly is that the majority of species within those landscapes are perennial, and they're composed of diverse populations. So there's many different plant functional groups all working together to build the productivity of that landscape. And these grasslands tend to be highly stable under variable climates. And it's where most of our long-term soil carbon is stored, is under those grassland landscapes. And for agriculture, it's generally used in grazing systems. So if we compare this to our cropping system landscapes, to grow a crop, we remove all the endemic plant populations and we sow annual crops as monocultures. And then once they're harvested, that stage needs to be reset for the next cropping phase. And so in ecological terms, we've simplified that landscape, and it's highly disturbed because of this constant need to re-establish the crop each year. And the productivity of those landscapes is supported by ever-increasing inputs of energy, essentially. So we support the growth of those crops through diesel for tractors, fertilizers, pesticides to maintain the health of the crop and that type of thing. And then while this type of farming has been very successful in feeding humanity, it comes at a cost. And so we see that many cropping areas that transition from perennial-based landscapes to an annual-based landscape is generally considered for the rundown in soil organic carbon that we see in our cropping soils, and increased levels of erosion and excess nutrients ending up in our waterways. And it's not only this transition from the perennial to an annual landscape, but it's the scale at which we operate these types of cropping systems. So our food security is reliant on our ability to produce grains. About 70% of our calories that we consume as a population come from annual grain crops, and these occupy about 70% of our agricultural land. But the majority of those calories come from just 3 crops in wheat, maize and rice, and you can see their production zones across the globe in this graph here. So we rely on just a small number of grains for our food security, but that limits our diet diversity, so there's much less of those cultural relevant crops being grown in different areas, and they're being replaced more and more by those big 3 grain crops. And also, because we're relying on just a few crops, it makes them vulnerable to climate. And it's climate change and climate variability. And so it's generally recognised that we don't have enough of the right types of diversity within our current cropping species to adapt to a variable climate. And that's why some new thinking about how we produce crops is required. So that leads us into why we're interested in a perennial grain crop. So there's 2 ways that we can develop a perennial grain, and the first is through domestication. So we can take a perennial grass and develop it for better yield and harvestability, and that's the same as what those early farmers did 10,000 years ago when we started developing agriculture. They took grasses from the landscape and improved their qualities to produce food. And so some examples of this is intermediate wheatgrass. So intermediate wheatgrass was introduced into the United States around the end of the Second World War, and it was developed as a forage grass, so for grazing animals. And then around the 1980s, when researchers were considering developing perennial grain crops, it was one of the species that showed potential to be able to produce grain for human consumption. And so the new research has sort of focused on that species in the Northern Hemisphere. But the one that we're excited about in Australia is mountain rye. So it's a perennial relative of cereal rye. And again, it was introduced into Australia as a forage grass, but it has these really unique grain qualities, which we think would allow it to be transformed into a perennial grain that would be suited to Australian conditions. So the intermediate wheatgrass in Northern Hemisphere is marketed as Kernza, which you may have heard about, and it's commercially sold for a range of products. It's been turned into breakfast cereal. It can be baked into bread, and very importantly, it can be brewed with to produce beer, which is sort of exciting. But it's similar we've found with mountain rye. It has good utility across a range of products, so it can be brewed with as well. It can be used as 100% wholemeal flour to produce bread, so it doesn't have to be blended with other flours to get the function in bread making, and it can be also used in manufacturing, so it can be flaked and used to produce muesli or breakfast cereals as well. Some of the advantages of mountain rye that we see over Kernza is that it has higher yielding than Kernza, and it's also 3 threshing. So when you harvest the mountain rye grain, it comes out clean off the harvester, whereas Kernza needs to be dehulled to be able to be used within the industry. But mountain rye, we've had no selection for any grain yield characteristics at present, and so that's the next type of work we'd like to undertake to be able to turn this into a grain crop. And we see just in our results from our trials that there's a range of seed sizes within the population of mountain rye that we have, and so it could be a straightforward process to select for individual plants that are high yielding and start looking at seed size and floral fertility to improve its yield. The other thing about Kernza is it's got this dual induction requirement for flowering, so it has a high vernalization requirement and a high photo period requirement to get it to flower, and so that limits its usefulness across most of the range of crop growing regions in Australia. But mountain rye doesn't have that same requirement, so that's why we think it's probably a better fit in terms of a perennial grain for Australian crop growing areas. The other way we can produce perennial grains is through what we call hybridization. So we can take an annual wheat plant and we can cross it with a perennial relative. And in this way, we can combine the grain quality attributes from the annual and link in that perennial habit from the relative plant. And that's been used to develop such crops as perennial sorghum and perennial rice. Perennial rice has been the poster child for the perennial grains movement. So large areas of commercial crop have been grown in China. And from the research and from field experiments, you see it can last for at least 4 years. It'll produce 2 harvests per year and yield the same as an annual rice crop with less inputs of labour and less inputs of fertiliser. And so it's been, it's enabled a real social change in the communities where they've been growing the perennial rice, because most of the workforce that produces the perennial rice is carried out by women. And so with less labour inputs, there's more opportunity for young girls to seek out other occupations and education outside of agriculture. But we've tended to focus on perennial wheats in our research. So that's a hybrid, and mainly because we think it's the easiest plant to go to fit into our production system, which most people will be used to. So in terms of how a perennial cereal will fit into a farming system, increasingly we're seeing the use of dual purpose cereals and canola to fill that winter feed gap in mixed farms at a period when other pasture growth is low. And we think that this is the best opportunity to incorporate a perennial cereal crop as a dual purpose because of its high dry matter production. And we've seen in other work that if we incorporate perennial cereals, we can lift farm profitability by 40%. And this mainly becomes about because we can rest other pastures within the system and we create a bigger feed wedge coming into the back end of the system, which means the producer can increase their stocking rate. But by using a perennial as this dual purpose crop, it increases the flexibility for the farmer because they've got more time to make decisions about whether to graze the crop or keep it for grain based on changes in seasonal outlooks or changes in commodity prices. And we also found that we can get high growth rates in young stock in grazing the perennial cereals along with annual cereals if we recognise that they're imbalanced in their mineral content, and we can remedy that by providing supplementation. So the particular minerals that we're interested in is calcium, magnesium and sodium. And so to improve the growth rates of the animals, we can provide them with supplementary salt licks to allow them to make up for that deficiency within the forage. One option for incorporating these new perennial crops into a farming system is through a phased rotation. And so we can use that early part of the rotation of the first sort of 1 to 4 years to plant the perennial crop and use it for grazing as well as grain production before going into an annual cropping phase. And this gives us a couple of advantages. Is one that we're producing grain over the full cropping phase, and so it takes the pressure off of needing to achieve high yields once we start annual cropping. But it also allows us to rotate different perennial crops into the system. So it allows us to take advantage of new cultivars as they become available, but also we can sort of start moving into using a perennial oil seed or a perennial pulse crop in that system as well by having that type of rotation. But the ultimate goal for the perennial grains is to develop these as polycultures. So rather than sowing the perennial cereal or whatever the perennial grain crop is as a monoculture, we want to be able to intercrop it with legumes in particular. And the legumes give us a couple of advantages. So the legume will provide nitrogen to support the growth of the crop, but the legumes also have a different mineral profile to the perennial cereal forage. And so if we can choose the right legume, which have higher concentrations of calcium, magnesium, and sodium in their forages, the animals can then pick their own diet to meet their mineral needs through grazing, and it could allow us to move away from having to supply supplements when we start grazing those crops. So just in conclusion, perennial grains are coming, and we see the success overseas of things like kerns and perennial rice, which gives us confidence that we can develop those types of crops for Australian conditions. Particularly mountain rye has a high potential, we believe, for our environment as the first commercial perennial grain crops. The perennial wheats still need a bit more work in terms of getting their persistence to be longer than the material that we have at present, and also sort of maintaining grain yield over time. So that's, where I'd like to conclude this presentation, and happy to take any questions.
Thanks, Matthew. Super interesting. I've got a question from Rob. Is the grain head a 2-row species, and does that mean its yield is in the length of the head?
So it's similar to wheat. So the perennial cereal that we're working with is similar to wheat, and the mountain rye is similar to cereal rye. So there's 5 to 6 florets in a spikelet. And what's driving yield in these is the number of tillers. So traditionally it's grain size drives yield in an annual crop, but in these perennials it's the number of tillers that we can produce that's driving the yield potential.
With the diagram that you shared, so the lifespan of the perennial rye is around 4 years, is that right?
That's what we've found so far, yeah.
Yeah. From Robin, do you know the sugar content of the mountain rye? I come from a horse background, and there is a concern for the sugar content of annual rye, which can lead to EMS and laminitis. So
so in the forage or in the grain, I guess we probably need to clarify. And we've found, we haven't measured sugar content per se, but water-soluble carbohydrate, which might be a proxy for sugar content, and that's sort of similar to what you might see in Phalaris or Torfesci.
Well, thank you.
So
Feel free to
it's very high quality, so high energy, high digestibility in all of these perennial cereals. But in terms of animal production, for perennial wheat, it's this imbalanced mineral content, so particularly magnesium, calcium, and sodium, which is particularly important for ruminant animals because they're very high in potassium, very low in sodium. And for ruminants, that reduces the absorption of magnesium and calcium. So it can lead to some of those metabolic disorders around grass technique and milk fever. And so we know even in annual cereals, it's the same. And if we supply those supplements, then we can get better growth rates out of the animals in sort of sheep and cattle. For monogastrics, I'm not sure.
Rob has asked, does that mean because it hasn't been hybridized, it will have a bigger root system?
Well, being a perennial, this is the mountain rye, I guess you're referring to. It does have a bigger root system than the cereal rye, but the hybrids have a deeper root system than the annual crop. So they invest more of their carbohydrate from photosynthesis into growing roots than an annual crop does.
What, like, is it, are you harvesting at a similar time that you would be harvesting wheat or rye, cereal rye?
Yeah, so the material that we have at the moment is very long season. And so we're harvesting, it's a later harvest because they're flowering a bit later. And so that sort of restricts the environment in which we can grow them at present. But because of the, particularly in the mountain rye, because of the diversity within the population that we have, we want to try and select for individual plants that are flowering earlier. And so that gives us the opportunity to push it, further west into the wheat growing areas.
How long does it take to produce another head to harvest?
Sorry, what was that again?
How long does it take to produce another head to harvest?
So in the mountain rye, after harvest, it'll still remains vegetative, but we won't see grain heads or flowering until the next spring. In the perennial wheat hybrids, one of the issues that we're facing is that it wants to go reproductive again after harvest, and so it'll try and flower again in the autumn. And so that's one of the reasons why we think they're not as persistent as some of those perennial grasses, because it's using energy to produce another grain to the strata rye rather than using that energy to form structures to allow it to be or survive over the summer. And so our work now with those is looking for those individual plants and trying to breed different plants that have that lower ability to try and have an ability to remain vegetative again after the harvest and not try and go reproductive again. So
is there
for the true perennials like Kernza and mountain rye, they remain vegetative after harvest, but won't go into that flowering period until the following spring. And because you've got that period after harvest through into autumn of green material, offers another opportunity for grazing.
Do you anticipate it will still need to be supported by certain fertilizers? Do you anticipate it will still need to be supported by certain fertilizers to provide mineral energy in low fertility situations?
Yeah, so the mountain rye sort of is sort of suited to low facility sandy acidic soils, so as a starting point. But because we want to develop these systems as intercrop systems, particularly with the legumes, then we get sort of that fertility function by the combinations of plants that we put together, and sort of reduce the need for external inputs. Probably similar to a conventional pasture, you might have to top up with phosphorus occasionally, but with the grazing of these crops, it also gives us another string to the bow, because the grazing animals help cycle more of the nutrients, and so they become available to the plant as well.
From Robin, is there any more research with indigenous grasses as perennial cereal grain alternatives that you know of?
I mean, there are, and there's a number of groups working on that, but we haven't got into that field as yet.
Can you speak a little bit more about the grain quality of the mountain rye?
So yeah, we've been looking at sort of the end use function of a number of these grains, and particularly with the perennial wheats, when we look at some of those predictive tests around quality, it would suggest that they haven't got the right protein content for bread making on some of the presumptive tests. So if you understand sort of rheological properties that they look for in bread wheats, comparing them, that they look quite different. But when we actually go and take them through to that next stage of actually baking with the perennial wheats, they've performed a lot better than some of the annual wheats that we've used as control. So we've got better life volume, better crumb structure, and some of the bakers that we're working with, so they've got improved flavour compared to some of the wheats that they were traditionally used from annual crops. So it sort of means that some of those presumptive tests aren't able to predict the end use function in these perennial grains, because we've moved away from a cereal that is not really wheat anymore. But looking at the baking test, they look really good, and that's a positive for the farmer because it means we're producing a high value grain, which improves the profitability of their system. And we've also been doing a lot of work on looking at what the animal performance is on these grain crops, particularly the intercrops, and looking at sort of the meat quality aspects of the animals that have been turned off after they've been grazed. And we see we're producing meat that's got high vitamin E content. So vitamin E is important for shelf life, and it's the results that we've had show that 20% more vitamin E in the meat from animals that are grazing a perennial wheat compared to what we see in other grass-fed systems. And another important aspect is the omega-3 fatty acids in the meat of these animals is also 2 to 3 times higher than what we'd see in a normal grass-fed animal. And the omega-3s are important for human health in terms of heart function and heart health. And the levels that we've seen were so high that it could be claimed as a source of vitamin E in a human diet. So that was very pleasing as well.
Back to the grain quality piece. Sorry, are you baking with this flour as a whole grain flour, or is it being?
Yeah, so 100% wholemeal flour.
Yeah.
And it's baked beautifully across different range of types of baking. So we've seen rapid dough formation bakes well, but also in more sourdough, long ferment type production systems where we can use it as a tin loaf, where it forms the normal bread that you'd normally sort of can see at Woolworths or something like that, but also works well as a free-form hearth type loaf, so it'll still maintain its shape without having to add other flours, to improve the function.
From David, do these perennials contain gluten? I assume they do.
Yes, they're not gluten-free, so they're still a cereal.
There's a comment from Rob that he assumes the mountain rye has certain I can never say this word, allelopathic properties to inhibit weeds.
We haven't tested for that, and not seen it. I guess we haven't been looking for it either, so I can't comment really.
But it's competitive, like you don't see it get. Or how do you manage?
Well, I mean, that's the thing about the perennials. So that's how we control weeds. I mean, they're not in establishment. They're still vulnerable to weeds, but once they start growing, it's their competitive advantage we use for weed control, as well as being able to graze those crops. And because they produce more biomass than an annual cereal, that's where their competitive comes from. So they produce a bigger plant, which then competes with the weeds, and particularly in the second year, you get a decrease in the amount of weeds, which are generally annual weeds, because the perennial has started its growth a lot earlier than what the annual would, and the perennial then is able to outcompete those annual weeds.
Are you, in these breeding scenarios, are you monitoring fungi to bacteria ratios or any soil biology?
We haven't as yet, but some of that work has been done. For the mountain rye, there's some work looking at sort of endophytes, which tend to occur in rye, and so we're looking at whether there's some endophyte sort of colonization within this plant, which may help with abiotic stresses. But there's been a lot of work done on overseas on the perennials with mycorrhiza and those types of relationships, which you tend to get once you shift away from an annual to a perennials. You start to have more of those biological interactions.
Yeah, I think that's what's really exciting. Like if you're looking at Dan Kittredge's work or the Bionutrient Food Association and how they're linking soil biology to nutrient density, like this is a real opportunity from that perspective.
Yeah, I've done a little experiment looking at perennial sorghums and some of their soil bacteria relationships, and there's some mycorrhiza that sort of will inhabit the roots of perennial sorghum and give it some ability to obtain some atmospheric nitrogen.
Yeah, right. So how does it, like what's next for you now with mountain rye? Like how does it work? When does it become like available to farmers? What's that
So
process?
we're sort of just doing pilot crops at the moment, trying to get engaging with a couple of farmers to grow the crop and then connect them to industry. So we're sort of developing the market for mountain rye while we're trying to develop the cultivar as well. But the next process is to start, looking at large numbers of individual plants and selecting for the qualities and characteristics that they're after to try and turn it into a perennial grain crop. And that's sort of the next process that we want to undertake. So the brewing industry and the bread making industry are, very keen to see these crops advance, and they're happy to take that grain and use it in their production systems.
How does it work in the brewery context? Like, is it
So we
comparable?
just had a little project finish where we sent some grain to some distillers, and they've made a rye whiskey from it, plus a range of brewers. And they've in the brewing, it works across a range of different styles. So from like pale ales through the lagers, it's performed well in the brewing process, but also different flavour profiles that they get from being able to use the rye mixed with the barley or malted barley. So yeah, it's been very pleasing, and again, it's sort of promoting that crop within those different industries. So we've got that market created once we have the plants that farmers will start growing more broadly.
Did you think when you got into this that you would be getting to sample beer and bread and part of your research work?
That's been one of the side benefits.
Rob has asked, what would its hectoliter weight end up being?
So it's at present it's lower than what we'd see in a traditional crop. So traditional annual wheat sort of weighs about 40 milligrams per thousand seeds, whereas these perennials are sort of 20 to 30 milligrams per thousand seeds. So they are lower yielding, but they produce a huge amount of biomass, and that's why we want to develop them as this dual purpose crop, because we can use that extra biomass to offset the lower yield. But still, we've got quite high grain quality in the grain that we're harvesting, so it's of a high value grain as well.
Maybe you've already covered this, but with the grazing, are you kind of approaching it in a similar way that you would graze feed wheat, or what do you call it, like forage, like a dual purpose wheat crop, like you have
correct.
To graze it at a
So
particular.
we're using that forage production over autumn and winter.
Yeah.
And because the crops that we're working with are longer season, we can extend that grazing into mid-spring and still not affect their grain yield. So we've got this long period of grazing and still be able to harvest grain at the end of the year, which supports their productivity for the farmer.
Yeah. And then in terms of when it's kind of getting rolled out across a broader area, like where are you are you targeting kind of farms around Cowra, or are you going further afield at this stage?
At the moment, we're sort of targeting the tablelands because that's where more and more of these dual purpose crops are growing. So traditionally, the tablelands have been the production system is based on grazing perennial pastures, and those farmers are trying to diversify their system by including grain crops, particularly dual purpose grain crops. So we see that the perennial offers a real fit for that system because that's where they're most suited to it at present. And it gets away from some of those environmental effects that we see for converting perennial landscapes to annuals. And so if they can use these perennial grazing or dual purpose crops in that system, it allows them to get that diversification and grain production, but still be able to use a perennial in their system rather than an annual. And then as we develop these plants further, the goal is to be able to shift it further into the Western, more grain-focused production systems once we get the persistence and consistency in grain yield improved. And again, that's about selecting those plants that flower earlier than the current ones that we generally see.
And were you saying that the kerns that's not grown commercially in Australia yet? That's an American.
No, and because it's too long a season, it's sort of restricted in the landscape. We think that it'll actually fit for Australia.
Yeah.
Because it's more used to those northern states in the USA where they get snow cover over winter, and so they're getting the vernalisation requirement through that cold period. We don't get enough fertilisation in enough areas in Australia to have wide adaptability.
Yeah. Rob has asked, does it have a higher silicon content?
Couldn't tell you.
Well, if there are no more questions, everyone, how do we stay in the loop about this this project? Like if farmers are interested in it, eventually trialing it when it's more widely available, how do they stay in touch?
So we're publishing quite a bit, so in scientific journals, but we're developing a web page on the DPI website devoted to perennial grains, and so I guess to keep up to date, that would be the first port of call. Let's look at the DPI website, but I'm happy to leave you my details and people can contact me directly if they like.
Awesome, thank you. Oh, there's one question from David. Do they have good pest resistance?
Yeah, so that's, one of the things that we're mindful of. So even in breeding perennial cereals, we've got to be mindful of resistance genes for different pests and diseases. And that's one of the ways in which the perennial wheats were first developed, was trying to integrate gene resistances from those perennial relatives into the annual wheat. So by making those wide crosses, it just so happens that some of those initial crosses tend to be perennial, and because to get them to be perennial, you have to have the full genome come across from that perennial relative, and that also brings in multiple gene resistance for different diseases. So we know in the wheats we've got good resistance to stripe rust, leaf rust, some of the viruses like yellow those mosaic, yellow dwarf virus that you see in wheat, and some of those types of viruses that transmitted by aphids. We've got those disease resistance built into these perennial crops, and the perennials naturally, because they've got to survive in the environment for a long time, tend to have these resistance genes already in them.
that answer your question, David? Fantastic. Okay, well, thank you everyone for jumping on, and thank you, Matthew, for sharing. We'll share a link to the DPI website. Did you say there was a link? Yes.
Yeah, I'll get that to you.
And we've also got another plug for our practice guides there in the chat for you to have a look at. Yeah, thank you again, Matthew. Appreciate you sharing what you've been up to. It's a really exciting field.
Thank you. It's a great honor to join the webinar today. Thank you very much.
No worries. See you, everyone.